Assalamu alaikum warahmatullahi wabarakatuh. My name is Mahmoud Gamal. I'm here to present the project with title Automated Warehouse Inventory Management System using drone technology and RFID system. So the objectives of the project are to build a system of a drone flying autonomously by indoor navigation system to scan the tags of inventories from racks and relay the information back to a dashboard in real time. To develop the indoor navigation system to be capable of communication with the flight controller and to investigate the drone performance in terms of flight time and accuracy. Here is a flowchart of the working system. First, we install the indoor positioning system, which are station beacons and mobile beacons. Station beacons mounted on the racks and mobile beacons mounted on the drone, and all the beacons contact with each other to calculate the distance and get the coordinates. After that, we adjust the parameters because before flight we have to make sure that we get very good tracking without any fluctuating in movement. Once we have a very good signal, we now have a flight area. This flight area have XYZ coordinates with any point inside it, including the drone position. So we can see or we can get the coordinates of the mission, the points in the mission. And once we get these coordinates, we upload it to the code and run the mission. So by running the mission, the drone, the mobile beacon feeds the code with the current location coordinates continuously, and the drone move to target point, and during the movement the drone will calculate the distance. So the drone reach to the target point with tolerance around 20 centimeters. After that, it goes to next point, etc., and until finish the whole mission. And during the movement of the drone, the RFID reader mounted on the drone will scan all the tags on the box, and all of these data will be monitored on the dashboard. We have built a hexacopter with around a total weight 2.5 kilograms, and with thrust weight ratio 2.4 to 1. The drone can fly for 19 minutes, and this flight time could be increased by increasing the capacity of the battery. So we are using optical flow to control the movement in XY, and rangefinder to control the altitude of the drone, and mounted two mobile beacons on the drone to get the current location of the drone and the orientation as well. Also station beacons, we are using 4 station beacons, and Raspberry Pi to control the code, and Pixhawk to control the drone itself, stability, and get the orders from Raspberry Pi.